Hello, my name is Ola Kalander, and today we will take a look at how you can create your own solutions using Novacura Flow with SQL Server as the data storage. It is good if you have some slight experience, at least of working with Novacura Flow, or at least been taking the basic training we have on our product. And we will be covering Microsoft SQL Server fairly from the top, I think. So a little bit of knowledge can't hurt, but we will start from the beginning there. So no real experience in that field needed. And even if you do have some experience on it, it could be actually pretty good just to a little bit fast, maybe browse through this basic part of the training, because there are some tips and tricks and best practices in regards how to when you're working with Microsoft SQL Server and Novacura Flow that can be good to know about. So even if you feel pretty good and confident in Microsoft SQL Server and Novacura Flow, browse over this training, I think, and then it's easier to understand when you come to the advanced sections what we're talking about. We have put the training material up on Gitbook. So on novacura.gitbook.io/training, you will find the training material for this training course. And since we don't really know if you are going to just watch the video here or rather follow along in the training material, I'm not going to stop to tell you that now it's time to do exercise 1 or 2 or stuff like that. So it's just I'm going to show you the exercises, how they're done, and maybe by recommendation you could do the exercise right after in the same way. You have the code most oftenly in the training material. But we're not going to pause and say now it's time for exercise 1 and 2 and so on and so forth, since that will be a little bit limiting in the way you are consuming this training. So in the basics part of this training, we are going to take a look at tables, views, diagrams, primary and foreign keys, joins, and a little bit about logins, users, and security. Prerequisites are that you need to have access to a SQL Server, and you need to have, if not sysadmin, you need to be a DBO at least on one of the databases. If you don't have a SQL Server at hand, you can download the SQL Server Express version for free from Microsoft's page. And then you'll also need the SQL Server Management Studio that we're going to refer as to SSMS. Installed on your PC. That is backward compatible, so just download the latest version. In the training materials, I'll put the links to both the SQL Server Express version and to Management Studio for download. I'd like to start off by discussing a little bit about naming standard and also the casings around it, or casing, upper lower initial letters. So first off, I think singularity is a good rule of thumb when creating tables and views or functions or stored procedures, what have you. Then by single form, I obviously mean that name, if you are going to create a table called project, call it project rather than projects. And same thing with employees. It is sometimes it feels more natural to have the plural tense of it, but singular always works. So I think we should stick to singular. Just a recommendation. It will still work if you're using plural, but it's neater if you have everything in the same grammatical form in your big solution. And then we have the casing, which is, I guess, what you're used to most of all. But we've ended up at Novacura with a recommendation to use what the internet is calling Pascal case or upper camel case. The difference, I found this image was pretty funny, that describes the differences a little bit, and where many people I've seen, maybe if you're coming from a more of a developer world, you're used to using start the first letter with a lowercase for variables and stuff like that. So it feels natural to start with a lowercase. But the issue is when you are creating a table again, like project, it doesn't look so good when you are not using a capital letter on the letter P there. So we're gonna actually in this case stick to primarily this Pascal case where we start everything with a capital letter. The ironic exception here is going to be a little bit later when we are creating views. To indicate that it is a view, we are actually going to use a lowercase v in front of everything. So there is no rule without an exception, right? And then we have some best practices around creating tables as well. When you are creating new tables, always try, if possible, to create 4 columns in every table actually. One called row created DT for datetime. We're gonna discuss data types a little bit in the upcoming minutes here, so don't get hung up on the datetime too here. So if we create one column called row created DT, we can put a constraint on that is always going to put the current timestamp when the row is inserted, which is really good actually. Then you, for whatever reasons, you might want to know when that row was created. It's never bad to have, trust me on that one. And then we have 3 more called row updated datetime, row created by, and row updated by. Those we need to handle manually in our flows when we are updating or creating rows, because we can't get that from the SQL Server. These are 4, I tend to call them logging tables. They are good to have. I would strongly recommend to create those for each table. And as we will take a look at later on, it's when you have one table, you can just script that table to create new tables, and then these will come automatically. And if it makes sense, we could try to only use one primary key where we tell SQL Server to automatically assign a key to that row. This is called identity specification in SQL Server. We will look more in detail at this in an exercise in just a couple of minutes. So we will clear that out, I think. But sometimes it doesn't really make sense to just have one primary key. Maybe you need them on 2 tables. But as a rule of thumb, try to keep them on a primary key on one of the columns. And also try to name the primary key the same name as the table, followed with an ID. So for example, again, we have our project table. The first column would then be project ID. And then we can make that as a scope identity. So SQL Server will automatically assign a new number to each row. Again, this will come in exercises, but a good rule of thumb here as well. Okay, let's just discuss data types for a little bit, and then we'll get into the exercise and start doing stuff instead. So I want to cover here the difference between first char and varchar, where the difference is that char is always a set amount of characters. So if you have a data type called char5, that will always be 5 characters, no matter how many letters you actually have typed. While varchar will be of variable size. So 1 bit of the actual data type will store how many letters the data type is. So if you create a variable called varchar5 and only type high in there, it will only be 2 of those. It is always better to use nvarchar or varchar instead of char or nchar if you are not exactly sure how many. I mean, sometimes it's just going to be PRD or TST or something, and then you know how many letters there are. Then it could make sense to have char or nchar. Otherwise, it's normally just better to use nvarchar. That's standard. And what is the difference then between nvarchar and nchar? That is something called Unicode. And Unicode is a simplified explanation of Unicode could be that it supports for special characters. Like in Swedish, we got these O, A, Ö, which is O's and A's with umlauts and stuff over them. The Japanese has their set of letters, Cyrillic letters, and also actually later it's given support for emojis and stuff. So yeah, the Unicode has support for all of these characters. What you put in is what you get out. So to illustrate this, I'll just create a new query in my SQL Server Management Studio. For this exercise, it doesn't matter what database we are in, so I'm just going to paste the code, and I'm going to make sure that my results is not sent to grid, but rather sent to text for this to be presented in the best way. And I am setting the no count to on just to make it a little bit more readable as well. So what we are doing here, we are declaring three variables. One is character 10, one is varchar 10, and one is nvarchar 10. And we are going to look at the difference between them. So in the first scenario here, I am just assigning my car test, the car 10, to hi, high, and I'm selecting that out to my result pane. So doing that, I see that it says hi here, but I can also note that there are white spaces here, 8 of them, I assume. But doing the same thing, also including my varchar test here, which is obviously then a varchar instead of a car. Running this query will give me hi and hi, they look the same, but if I highlight it here, I'll see that the hi has 8 spaces behind it, but where hi does not, because it only has 2. That is the difference between a varchar and a car. Moving on to the nvarchar, which means Unicode. So if I am doing the same thing here, I am inserting the text hi with a smiley face here. This doesn't have to be an emoji, obviously. It could be a special character in a strange language, like Swedish, for instance. And selecting this out to my result pane will yield 2 question marks, because it doesn't really know what this sign is. It can't really show it to me. While if I am inserting, I need the n here as well in order to tell to SQL that this is a Unicode in the insert. And then I am selecting the nvarchar test emoji sign or row variable, I will get the emoji presented here. So this is the difference between varchar, and also the difference between nvarchar and ncar, which is Unicode. Continuing on the data types, next data type to cover here is date and date time. And date is just the part of date time. So if you this is a little bit different from Oracle if you come from that world. So in SQL, Microsoft SQL, we have date and date time. So if there is just the date, you can use the date, and if you have timestamps as well, you'll need the date time. And then there is a new or fairly new data type in Microsoft SQL Server that is called datetime 2, where you can actually set the granularity on the smallest, least significant digit in your timestamp. So just datetime brings in 3 milliseconds to each timestamp, while datetime 2 you can set if you want to have 0 milliseconds. That will be with the 0 in parentheses after the datetime. Or you can set 7 if you want to have 7. That's not going to be milliseconds. That's going to be, what is it, picoseconds? Some very small unit of time at least. I normally, I don't know, just milliseconds is a little bit abundant for me, I think. So I am normally sticking to datetime 2 with a 0 afterwards, just to indicate that I don't need the milliseconds. It's fine with the second in the very common cases. So we're going to use that actually in the common examples here. But you know, datetime 2, who cares? It doesn't really matter. There is also like a little bit of a bug in SQL Server that I'll show you later on, that or you'll see rather, because I didn't notice it itself. I just saw it when I reviewed the video. That when you enter datetime 2 and you put a 0 between the parentheses and you tab out, it sometimes sets I think it's a 7 in the parentheses. So be a little bit wary about that. And apart from that, feel a little bit free to use datetime or datetime 2. Doesn't really matter. And then we have the hierarchy ID, which is might be a very unappreciated data type in when you're working with lots of data in a hierarchical structure, and that is a really hard word to pronounce. But so normally, or if you have a parent, that could be an organization chart or any other types of hierarchy you're working with. You have the options to work with either a parent-child structure and something called CTEs, common table expressions, which becomes a little bit tedious actually to work with. While this hierarchy ID, you can put an infinite number of tasks or subunits to whatever you have and have a self-reference parent-child hierarchy, and you can use SQL functions and you can put indexes on them to make them really fast actually. So hierarchy is a pretty good thing. We will cover that in a later training, not in the basic section, but in the advanced section. We will make some exercises with hierarchy ID because it's been useful to me at times. We're now going to take a look at how you create a table using the user interface in Management Studio. So going into your database that you have assigned for this training session, expand it, right-click on the Tables folder, and create a new table. In here, we first get to set all the column names. And we are going to name this table project. So what I am doing according to best practices, I am going to call my first column name project ID, which is going to be a data type of an integer. And since this will be my primary key, and I want SQL Server to automatically assign a new ID to it, I'm going to set it actually to be an identity, what it call it. So the identity increment is how much will this be incremented for each row, 1, 2, 3, 4, 5, 6, and so on. If I would set 10 here, it would be 10, 20, 30, 40, and so on. And the identity seed is where it should start. So right now I want this to start at 1 and increment it by 1. Next column we are going to create is project name, that we will assign the data type n varchar, since we want to have support for Unicode, and it could be variable in size, and I want to make it max 100 characters long. And then we are going to create our best practice for columns here, where one of them is row created dt. That is going to be a date time, and here a trick I could do, I could set it to date time, that is fine, but that is going to give me milliseconds, and I don't find that very important oftenly, so I'm just going to use the date time to data type instead, and manually setting the granularity here to 0, which means I am not going to get milliseconds. It's just going to be down to the seconds here. See how that when I tabbed out here, it changed it to 7. So using I don't know if this is a bug, but be sure to manually set it to 0 there. Then again, as a best practice, I want to have a column I call row created by, which should be an n varchar, say 150, and here this is where if we are using Flow to insert stuff, we will capture the username. So make sure that this is long enough for as long as the usernames are in Flow. It is also good to have something maybe called row updated dt, which is also a date time 0. I'll just copy that from here. And then something called row updated by could be good as well. Updated by, and that should be the same data type as I had for row created. This way, we will know when the row is created, and who it is created by, and we will know if it is updated and who it is updated by. 3 of these we need to have support for in Flow, or however we modify or insert the rows, so that we make sure that we always add that into our flows. While the row created date, we can actually set a default here in SQL Server. So I'm going to give it a constraint that is called get date parentheses. This means that whenever the row is created, SQL Server will automatically add the current timestamp to the table. This is very good to have actually. It's so good when you need to remove something or you need to fix something. It's really nice to know when the row is created, so you know if you created it or something else and whatnot. So try to always at least use this row created DT, the DT for datetime. Okay, and when I am done with this so far, I'm just going to have project ID and project name. I'm going to set project ID as my primary key. And then I am going to save my table by clicking on the floppy disk up here. And this table will be named project. Looking in my table, I see my table project right there with my columns. And here down we can see the row created constraint. Okay, so our key takeaways here from this session is that for naming standard, we are going with singular, for example, project instead of projects when we are creating tables and views. We're using Pascal casing, meaning that we start every word with an initial uppercase letter, so not first lower and then upper, with some exceptions obviously, but we'll mainly try to stick to that. Just as if you're creating a table called project and then you have something called project rows, it will be kind of weird to have project with a lowercase p and project rows with a lowercase p and an uppercase r. It's yeah, maybe in variables it makes sense, but totally not in when naming tables and views. And then when you are creating your tables, see if possible just have one primary key and try to call them the table name, no underscore, just table name and ID with a capital I. That will keep it easy and consistent, and it will be easy to know which key is coming from where and so on and so forth. Login columns. Try to at least have the row created datetime where we set the constraint to get date so that we will know at all times when each row is created. And then in addition to that, the other row logging columns, row updated by, row created by, and row updated date time. That is not going to cover all the scenarios, obviously. I mean, you're only going to see who's updated the table most recently. There are ways if you want to have more advanced logging on this that is called it's called an audit trigger. So we put a trigger on the table that will save all the changes into a different table. That way we will store all the changes. We will go through this also in the following sections, but as a very basic, try to keep these 4 logging columns. I think that is a good means of practice. Now that we have our project table as we like it, we will of course use that as a base to create our next table. So I will go down, I will right click on my table, go down to script table as, create to new query editor window. I highlight project, and if I press either Ctrl H or go to edit, find and replace, quick replace, I will choose to replace project with task. And note how it then will replace my table name, my 2 columns. I will use the same standard here. It will also change the name of the constraints here, and it's important that you make sure that down here in the alter table that it will replace the name of both the table and the constraint name. So doing that, replace all. I see that the 8 occurrences was replaced. But before executing this query, we will add some columns to this table. So right after task name, insert, make sure to also add 3 columns. One is called parent task ID with an integer. One is called product ID. This is so that we can build a foreign key to our newly created products table. And then we will need a column we called a HID, and that should be hierarchy ID. We are going to discuss that more in detail later. Then pressing execute or F5 will execute my query. It won't automatically refresh my table column here, but if I go right click on the table, choose a refresh, I will see that I now have a project and a project task table. We are also going to need a resource table, so again I will do the same thing, but instead of project this time we will have something we called resource. Again, making sure that everything here is changed. Hitting enter, and I will execute. And then we will have an intermediate table between task and resource that is called task assignment. But this will not have a name. So instead of task assignment name, I will choose to map this to task ID, or just create the column for now actually. Task ID should be an integer. And then we also want to create resource ID that is also an integer. So we will look more into detail just in a bit how we connect the tables, but for now make sure that we have a task assignment where it has its own ID, and we have a column that has the same data type from task that is called task ID, and same with the resource ID. So this is just going to be the many-to-many tables lying right between them. Hitting F5 again will execute. I'm just taking a quick look down here that I am actually changing my new table here. Pressing F5, refreshing my table folder, and now we see that I now have project, resource, task, and task assignment. And they should look like this. If they don't, please go in and correct that. And maybe the easiest way to change something is to right click on the table and choose design. And now there could be so that you have a setting that I'm going to show you what that looks like. So if I want to change row created by to say 250 for this row, and trying to press save task assignment here will give me an error saying changes is not permitted. And this is something that it's a little bit weird, but every time you install SQL Management Studio, you need to go into options, designers, table and database designers, and here there is a little checkbox saying prevent saving changes that require table recreation. Since we are developing now in SQL Server, we're going to do this a lot, so just uncheck that and click OK, and then going back here I can now save my table. I digress. I want it to be 150 actually rather than 250, so saving that again will update my table. Okay, let's take a look at foreign keys and how to keep data consistency between tables. We're going to use database diagrams for this. And although Microsoft has hinted that they are going to discontinue the database diagram in future version, and especially in Azure, I know they've been receiving lots of criticism against that. It is actually a pretty nice feature, so I'm honestly thinking that they are going to change that decision and continue with database diagrams. I am anyway going to use it now because it's a very good way to get an overview, and it's an easy way to work with your own structure of tables. Let's just hope that they're going to give good support for it. There are obviously ways to do this manually, but it's more cumbersome, more codey, so I'll just use the diagram. So under your database here, choose to create a new database diagram, and it's going to ask if you want to create it. And now it might be so that you get an error message, and that looks like this. And the reason for that is, depending on what user you were when you created your database, or if someone else has created the database you're in right now, it might or might not be so that under files that you have an owner there. So if you don't have an owner, you'll get that error message. So if so, just set the owner, SA maybe, as the owner of that. So anyway, okay, going back, new database diagram. I'm going to choose to create my database diagram. And for this, I want to add all my 4 tables that I just created. Closing the window. And you see I have my 4 tables I'd like to work with here. I can rearrange them a little bit. In this case, remember how I wanted the task table to be connected to the task assignment, or the task assignment rather is in the middle table of my many-to-many relationship. And then I have project that should be connected to tasks. In here, we can also change names and length of columns. Right now we're having the standard table view, but if we choose to, we had column names. If we choose the standard view, I would see my my data type here as well. So in the last, what was it? I tried to update row created by. I might as well do that here actually. But we're going to leave that for now. Going back to the column names, so it looks like this. Actually rearranging it a little bit here. So now I want to connect project and task tables with each other. So I'll just grab the column here with the left bottom of the mouse, dragging that column up to my project ID column in project. So I am dragging my foreign key to the primary key of my primary table. And I will get a pop-up message like this. What do I want this relationship to be called? It's perfectly fine as SQL decided for me. I'm going to click OK, and we can take a look at here that just to make sure this is probably going to be fine, but under here, tabs and column specification, we can see the foreign key base table, the foreign key column, the primary base table, and the primary key column. So clicking OK here now will set up the relationship between project and task. The asterisk here indicates that I haven't yet saved my changes to the database. So in order to do that, I'll click the floppy here to save my diagram. I'm going to have to give my diagram a name, so maybe task, perhaps I want to call it. This is just the name of the diagram. So, but when I am saving my diagram, it will also write the changes to my database. So now that the asterisk here is gone, I know that we have a connection between my task and project table. And so what does this mean? Primary key and foreign key. I assume that the easiest way, if you don't really know, is to work a little bit with it. But to try to explain it simple is that right now I have a foreign key to my project table, meaning that when I create a task, it has to have a project, or the project ID has to be a null value, or SQL Server is going to throw me a foreign key error message. Same thing right now. If I have a project with project that has several tasks to it, if I try to delete that project, it would prevent me, since there is a relationship here. So that is keeping the data consistency. But sometimes when we are developing our own solution, it could be very handy to be able to delete a project, or maybe the purpose of it is, the purpose of my foreign key here is, when I delete a project, I want all the tasks together with it to be deleted at the same time. So if I right click here on my foreign key relationship line and click on properties, I'll get this property pane over here, and I can see that in my insert and update specification, on the delete rule and update rule, right now there is no action. So say that I have 4 tasks. I have one project called A, and I have 4 tasks connected to that. If I am trying to create a new project now, or sorry, if I'm trying to delete project A, it would prevent me, since I have tasks. So it will just be prevented, throwing me a foreign key exception. Uh, and then I would manually have to go in and delete all tasks first before I can create the project. Sometimes that is what you want, but oftenly maybe you just want to delete the project and have everything else deleted with it. So then you can change the delete rule here to a cascade rule instead. That means when I am deleting the project, it will delete all the including tasks. Saving it will save the changes to my database. Then we'll also create a similar foreign key between task assignment and task ID. Dragging it there, making sure my tables and columns look good. And in this case, I will actually again do a cascade deletion rule between the two. Saving that just to make sure everything looks fine. It is not a bad idea to, when you do these sort of changes, to save between each foreign key creation or table update actually, because you could end up with some weird situation otherwise. So try when you're done, when you are satisfied with the creation of a foreign key, for example, just save it to the database. All right, so we will do the same thing from task assignment and resource as well, dragging the resource ID over to the resource table and thinking here, do I want the deletion rule between resource and task assignment? Maybe not. Maybe I want this to be controlled sort of from the project and task. So if I delete the task assignment should be deleted. If I delete the project, the task and task assignment should be deleted because it's sort of cascading the cascade rules here. But however, if I delete a resource, do I really want the task assignment to be deleted then? No, not really. Actually, I would rather prevent that. So I'm going to leave this deletion rule to no action. Saving my database, or to my database. Taking the opportunity while in here, I am actually going to switch over to standard mode here and insert two columns in my task table. One will be start dt, date time 2 again with the 0. Making sure my 0 sticks, which is for weird reasons it's not. And then I'm also going to add another column called end dt. Same thing there. I'll just copy this one actually right over. Making sure my 0 sticks in here. If you don't want to be bothered with the datetime 2, the datetime is fine. It's just that you get the milliseconds. I think the datetime 2 is cleaner. All right, see that I have the asterisk here, so I need to save this to push it to my database. And a word of caution here. So now I did a little bit of an intrusion. I went into a table and I created start date and end date in the middle here. That is just because I don't have any views or anything querying the task table. If you would have though, the view would not really get this the first time. There is a command called sp refresh view that you can run to update all your views. But I think as a good rule of thumb, don't do what I just did normally. Don't insert columns just in the middle here. Just add them in the end, either if you do it in with query language code, or if you do it here, or if you right click and choose design here. Try to put the newly added columns at the end. I know it's tempting, and right now, since I haven't been using these tables at all, I'm just going to actually put them a little bit better where they belong. But after a while, when you've been working with it, I think you're going to give yourselves problems. And there is also the benefit of having it last. You see what columns have been added. It could be a sort of a good change tracking as well. So try and do that. So our key takeaways for this session is that the primary key is the actual key of the table. The foreign key is a column that points to another table's primary key. Foreign keys are used to keep data consistency, meaning that we can prevent rows to be created or deleted based on the rules for these constraints. And also, we looked a little bit out when you're using the diagram or the graphical user interface to add columns to a table. Avoid to, when you're in production or at a later state, avoid to put the rows sort of in the middle. Rather just add them to the end of the table, even if it would make sense to have project name right out of their project ID, for example. But that has to do with that the views are not always recompiled, so to speak. So there is a function called, or a stored procedure, I guess, called SP refresh view that comes from Microsoft that you can use to force the view to refresh, to update itself on the changes you made. If you really want the columns in the order you want them, you can make it work. But as a good rule of thumb, just add them at the very end. In that way, you'll always see, or also see, in which order did you add the columns. Could be good to know sometimes. Okay, time to add some views to this story. A view is sort of a reflection of one or many tables. That it's handy. Some ERP and some systems use views to put security on the entire solution. We are not going to do that right now, but we're going to create some views to make our lives easier. For example, when we're using this in real life scenarios is when I've been working with, say, inboxes in Flow. If there are variables for inbox name, inbox description, the calendar, if it's a priority and stuff like that, having to go into each say I have 15 inboxes based on the same view, it would be very tedious to go into each and every one. So instead, I'd rather create a view that with a column that I call, say, inbox description, and then I can put whatever I want to into that view. And if we want to make changes, it's just one place to make that change. So yes, on to views. And some best practices around views is to always start your view with the comment section, and always comment your changes when you do changes to a view. You will someday thank you for doing that, or someone else likely will. And if you want to, you can name your views with a little lowercase v and then the name of the view. So if you create a view on the table project, you can call that a lowercase v project, P with the project with a capital P. That's just to make it easier to know when you're selecting data from the view or from the table. It is a little bit easier to see that when you're out looking at the query state. So I would recommend to start with a lowercase v for all the views when you're naming them. So let's create a view that reads to the task table. You do that with the syntax create view and then the name of the view. I'm going to call this v task and then as. And then we'll start with the comments section, which is first today's date. Today is created, so this is the only thing I've done right now. So this is where we keep the version logging, what we're doing and updating the view with. It's going to be good. And then I'll end the commenting here for now, and my view will be select asterisk from task. And then I've learned over the years that not a bad idea could be to actually put the selection there into task and also from my view, because when you script this out, you'll save some seconds by just running this script. Going ahead and executing by pressing F5 will create my view. So if I'd close my window here and check under views, I see that I have my view task here. Right-clicking on that script, create to new query editor window. This is what I mean, that when I do this, when you want to troubleshoot or something, then it's pretty fast to just run the task there, or run the query from the tables that are included in the view right there. It's just that one of those small things that's going to save you a few fractions of seconds over your life. So I recommend to do that. Actually, it's good, and it's also nice when you are looking at someone else's solution and you have that up here. You know exactly how to try it out. This could be more complex queries, how to try the view out and how to troubleshoot and so on and so forth. Okay, so when I want to do changes to my view, I'd either have to script it out as alter to, if I know I'm going to do changes in beforehand, or I can, in my code here, just replace the create with alter. Otherwise, I'm just going to show you what happens. It's going to scream at me that there is already something called this in the database. So that could be a good reason to have as a good rule of thumb, maybe to always script views to create as, just if you accidentally slipped on F5 or something like that. So always use create, and then if you're really sure that you want to change the text here to alter. That's just like a little good rule of thumb. All right, so then I want to change my code. I don't want to get everything here from my task in this case, but rather just a couple of the columns. And I'll show you a neat trick here. So instead of, it's the same thing in Flow. You know how we need the double quotes in Flow to give alias for the tables. So we can't just do a select asterisk in Flow anyway. So, but I have my columns here, right? So if I just drag this columns thing here over, I'm gonna get my columns listed like this. And in my view, maybe I don't need the row created and all of these in my view actually. And also if I run this code here, I'll get the HID, which is hierarchy ID. And in some cases, that is not working. Like in our portal 1, for instance, right now, at least some portals are going to crash with it, and that could happen because hierarchy ID is a little bit of a not so used data type, really effective, but not so commonly used. So in this scenario, I'll actually remove that as well, and executing the code will save my view, and I can run the code here, and I see I've narrowed it down a little bit. And another good practice is to give your tables, or my table, the only one I have in this case, an alias like this, T, and then actually has it as a good rule also to always put the T in front of your column so you know where they're coming from. It's I mean, it's pretty obvious now that I am in just one table, but if you have a few of them, it's really nice to know which table it's coming from. So do that as a best practice as well. And while we're here, I just want to show you something that has to do with the Intellisense and the cache. So say I am adding a table, alter table task, add, and I'm adding a column here. I don't know, demo, and that's an integer. So if I haven't added yet, so if I try to do this demo, if I try to run this from task, it's not going to like that because I don't have my column demo there quite yet. Adding this to my table though, now I know I have it there, so I can run the query and it works fine because it is there, but my Intellisense here, my window doesn't like it still. So I could either wait, I don't know if it's an hour or what the default setting is, but I can wait for the cache here to catch up, cache to catch up, or I can press Control, Shift, and R to force the cache to wake up, or to refresh rather. So you see how the red thing got deleted there. So if you are in here adding tables and you don't want to see this red thing, you could press Control, Shift, and R for it to force the refresh. Alter table task add. Okay, I want to drop column. This was just to show you how it works. Okay, so now that we know a little bit more about views, I'm going to use my existing view here, script it, create a new query editor window, and I am going to create another view that we are later on going to use in our scheduler portlet. So for that reason, I am going to call this visual planning. And just to be very correct here, I'm going to change that. And to this table, or in this view rather, I want to do some joins here. So say I want to join project alias p on p dot project ID equals t dot project ID. So this is how I join the two tables with a real ANSI join together. This is an inner join, so that means that it has to be a record both in the task table and in the project table. There is a lot of information out there about joins, left joins, right joins, outer, inner, full, so cross joins. So we're not going to dwell very deep down into the different joins. We're going to stick to full join and something called a left join. and that we will just come to shortly. But for now, I want to join project. I want to join task assignment TA on ta.taskid equals t.taskid. And then I also want to bring in the resources. So join resource R on ta dot resource ID equals R resource ID. So I can execute this now. So I have access to my view, and I can select from it. So yeah, like a good rule of thumb here, maybe we should add these here so I can select. So we have a quick way when we go in here to just select from the different tables, underlying tables here. And I need to change this to alter. There we go. All right, so if I'd like to see all tasks, and I don't really care if there is a project and task assignment, I would do a left join instead. And a neat trick here is if I press now the Alt key on my keyboard and highlight the rows here, I can just type left join. See how that worked? So say I want to remove the N here, I can do that. I do not want to remove that, so I want to add that again. So pressing Control, you can highlight the box and then making changes. This is supported by most advanced text coding tools and also in Microsoft SQL Management Studio. So that is a pretty nice way. So think of it here. I'm not sure we're going to tie projects to this actually. So that is perfectly fine with the left join. But for my task assignment and resource, they have to be there. So I'm going to make inner joins to those. So the result here is that we do not need a project, but I do need a task assignment and a resource together with my task records. So yep, selecting from visual planning, we don't have anything in here yet, so we just created the base of the view so far. Another way to select everything from either my table or my view is that you right click and you select top 1000 rows. It's quick and convenient, but please do remember that don't paste this entire code into your Flow or portals, because you don't want to have the database hard-coded there. Imagine that you are subscribing from test to prod in an environment, or you just exporting portlets and whatever. I mean, this is going to be to your test database. So if you do this and copy, I mean, I can run this, right, because I am in the same server and everything. But when you're moving it over to Flow and Portal, please always remove the database portion, because that is the way it works is that it's not sure it's going to be the same database when you're moving on to production. So good rule, always remove that part when you're scripting out and selecting top 1000. And I've seen this so many times that be sure to always remove this. It's the best way to work. And also don't forget to remove this if you want to see more than 1000, obviously. And while we're looking at graphical ways, there is also this edit top 200 rows. I don't use it a whole lot, but I know it could be an easy way to just add some stuff in here. So if I want to create task number 1, yeah, I'm actually good with that. Task 2, and if another thing I want to show you in here real quick is that what happens. So this is an integer, right? If I happen to try something, it's not gonna like that. So I need to press escape, because you're in a pickle here. You can't really get out of this cell. So the thing you need to do is to press escape. And a shortcut for if you would have happened to type a 5 or something and you realize, oh no, shit, this should be null. You can either type null or you can press Ctrl 0 to get the null value in there. Another thing would be, remember how it said edit 200 rows? I mean, what if, imagine you have 400 rows and you want to change something that is in the latter 200? Well, then there is the the SQL pane here, so you can actually modify your query. For example, do a order by or where statement or something, and you would only get those results, and you could edit those rows here in a graphical way. I do find it almost faster though to do it code-wise, and we are going to look a lot on that later on when we are using Flow to manipulate our data. So we will come to the how you do update, delete, and insert statements in SQL. But wanted to show you this. It's not super bad. It's not super good. It's a way to modify data if you don't want to create it by code. It's a little bit faster maybe. We could just clean up if we added some rows there. We could clean up our task table by running delete from task. That's all you need to do. You're going to clean out everything from your task table. So we start at a clean slate here. And let's take a look at SQL login, users, roles, and permission. In SQL Server, we first create a login on the server level. This is where you need to be sysadmin or user admin or something on the server. And then we assign the, or adding rather, users to the database based on that login. So the login has the password, but the user is what resides in each database. So there is a little bit of a difference between a user and a login. If you're working on a locally on-premise installed SQL Server, you can add and remove users via the graphical user interface. But in Azure databases, that doesn't work. You have to do it programmatically. So we're going to do that now to cover both scenarios. And here comes old grandma something, I don't know, but it is really easy to just create a user with a blank password. And I mean, if you're really sure that this SQL Server is never going to be exposed to the internet, I guess it's fine. But there are so many sniffing things out there trying to hack into SQL servers, and it's a really common way of attacking. So even if you put it on your laptop and you'll be on a public Wi-Fi on an airport, all of a sudden someone can access it. So just give every user a little bit of a complex password. Don't use your summer 2021 or anything like that. But I would recommend to use KeePass or a similar password tool like that. And from that, you normally can generate the password. And if you do that from there, you'll save the credential at the same time as you are creating them. So yeah, do that. It's a good recommendation, I think. Okay, popping over to SQL Management Server Management Studio to create some logins. One login for Mars and one for Moon. To create the logins, you need to be in the master database, so you can use the use master command if you are on-prem. But if you are on an Azure SQL Server, you need to select master from the drop-down list up here, since the use command is not working in Azure. So create login Mars with password and my secure password. Executing will create my login. So now if I refresh here, I have the Mars login. I'm doing the same for a login called Moon. Doing that will show me that I now have a login as well called Moon. But right now I'm still not able to log on to the actual to my database using Mars or Moon, because I need to create them as users as well. So if I switch to my database here, use my training database, I am now going to create, see here if we can see the users. We don't have any users here now called Mars nor Moon, so I am creating those right there, and refreshing will show me that I now have Mars and Moon, but those are just users based on these logins. I'll also add the Moon and Mars to my as DB owner, to the DB owner role in that database, in order for them to have some power there, and that is done by the sp add role member command. And to try this out, I can connect to a database engine, and I can try to log on with Mars. And if I choose remember password, it will store the password for me even. So connecting here, I am connected as Mars, while up here I'm connected as SA. Okay, so that was it for the very basics of the SQL or Flow and SQL training, where we've covered, and hopefully you have a good understanding by now, around, well, both naming standards and a little bit of best practices, and tables and views, diagrams, joins, inserting and updating tables, and SQL login and users. So moving on from this basic session, will give you a good start, I think, for the more advanced section, where we'll dive in a lot more into the weeds of how you can use Flow to build some pretty cool solution on top of Microsoft SQL Server. We will go into different things, but also eventually coming over to how we can implement the portal and put that on top of things as well. And then I guess the imagination is the limitation. So I hope this session has been initially giving you anything. Maybe it felt a little bit rudimentary, or maybe it felt super advanced. I don't know. Please like and subscribe on the YouTube channel here, and you can also post comments there if you think something is missing, or if you are seeing any errors and stuff. You can email me on this address, and we'll make sure to take a look at it, and and thank you for the for the support of doing that if you do. All right, have a good day. Thank you. Bye bye.